These notes are about separation techniques and mixtures. So the first type of separation technique is a physical separation. Generally, this can be done by hand because they're going to be larger objects and you separate them out based off their physical properties. So this would be like color, size, shape. An example would be like recycling. So when you recycle, you may put your paper and your plastics all in one bag, but then when it gets to the recycling plant, they're going to separate it out based off the type of material that it is, if it's a plastic or a paper or a metal, so they can recycle it. The next type of separation technique is by magnetic separation, and that's exactly what it sounds like. So magnetic separation separates objects based on if it has a magnetic ability. So you'll be separating metals from whatever you're trying to separate it from. So an example of this is metals in your cereal. So we're going to watch a short video about metals in your cereal, and then we're going to talk about it.
With a friend of mine recently, and she was telling me that common cereals have metal added to them. I mean, I thought this was absolute rubbish, but anyway, I went down to the supermarket, bought a bunch of common cereals off the shelf that were high in iron, and decided I would conduct a couple of experiments to see if this was indeed correct. The first things I wanted to do was to just put some of the cereal on top of a kind of bowl of water and see if I could magnetize it. So let's start with the total. So I'm going to put this in the water, and then I've got my magnet, and let's see if this actually does anything. I'm not touching it. I feel like I'm using the force. It's kind of crazy. And if I go above it?
Okay, so I'm going to fast forward it so you can see that how he did that with one piece, and now he has blended them together, and we're going to see what happens.
Man, that smells awful. Put the magnet in a bag. I'm just running the magnet around the inside of all of this, seeing if it actually picks up any of the filings. And look at that. See the black part around the magnet? That there is all the filings.
Okay, so you saw how one type of separation technique is by magnetism. So when you eat that cereal, that metal is not actually hurting your body. It's actually probably giving you some nutrients, but it's not large enough for it to hurt your intestines or anything like that. So that's not need to worry. Another type of separation technique is filtration. So a good example of this would be making coffee in the mornings, or so you're separating out a mixture based off of its physical state of matter. So most of the time you're going to be separating out a solid from a liquid. So filtering out coffee, or where you have your solid coffee grounds in a filter paper, and then you pour your water on top of it, and the water goes through the coffee grounds, and it separates out the water from the coffee grounds. But filtration is not just separating out liquids and solids. It can also be able to separate out different size particles. So an example would be a window screen. So a window screen can separate out sizes of gas and a solid. So you put up a window screen and it doesn't allow large solids to get through your window, where it does allow for liquids or gases to go through. Another type of separation technique is called distillation. Now, the distillation is separating out liquids based off their boiling point. So remember when we talked about states of matter, how when a substance gets to its boiling point, like water is 100 degrees Celsius, it starts turning into a gas from a liquid. And that's exactly what happens in distillation. And remember, this is physical properties. So we're going to do a small animation about distillation. So as you can see here, this is your distillation setup. It's kind of chaotic, but you're going to have a glass container that has a liquid in it, and then you're going to have your Bunsen burner, down here, and then any gas that's going to evaporate from the liquid is going to go into this arm, and water is going to go out, and this is where water could go in, and it's going to separate out. So we're going to watch this real quick. So as you can see, the liquid is starting to go down because the level of liquid is going down because your temperature is rising. So that state of matter is becoming a gas. You can see how those particles are starting to go away, and these particles are increasing. So we're going to watch it again one more time, and I'm going to explain the water going out and coming in. So you have your water going out. You can tell how the water it's increasing. So you're separating out two liquids. So over here you have your purple liquid, of course, and it's going to be separating out the water from whatever other liquid you're going to be using. Okay. Now another type of technique. Now, okay, this is really cool. It's called a distillation crude oil refining. So this is how we get our crude oil, is by cooling and then heating up oil over and over again rapidly. That's why there's so much vapor that comes out of those steam chimneys. You can see this a lot in Birmingham, how you'll see these oil refining companies, they're sending out, it looks like pollution, but most of the time it's just water vapor. Another type is evaporation. So you're going to be evaporating a liquid off of a solid generally. And like if you wanted to separate out the salt from the water in salt water, then you would boil your water, and it separates it out, and you're evaporating off the water, and it's leaving just your solid. Now ponds actually do this, which is I think is super cool. So you have some saltwater ponds, and during the summer when it gets really hot, the water will evaporate, and you're left with this like white bottom that is pure salt, and it's because all of that water has evaporated. Another type is density separation. So we made density columns. You're separating them out based off of their density. We've done this in class. Here's an example of a density column, but you're just separating them out based off their level of density, where the least dense sink to the bottom and the most dense sink, or the most dense sink to the bottom, and the least dense float. So like this blue liquid would be the most dense. And then this clear liquid up here will be the least dense. Another type of separation technique is paper chromatography. We did a lab in this in the class, where we did 4 different sets of ink, and then we allowed the water to go through the filter paper or the chromatography paper, and it separated out the ink based off the solubility of the colors. And you can do this with anything that has color pigment. So you can do it with carrots or grass or really anything that has a color. So we're going to watch a quick video about chromatography. Now this is not an exact example of it. It's an animation, and it's going to explain it a little bit better to you. Alright, so instead of listening to that music, I'm going to talk about it. So we have a mixture of these substances. That's what the colorful dots are. And the truck is going to drop it into what we are considering to be chromatography paper. Then we have this mobile phase, which starts to separate out all of the different substances. Now, the most soluble substance is going to go to the end, where the least soluble substance will stay towards the beginning of the paper. So you can see that the most soluble substance was red, and then the next most would be yellow, and then the next would be blue, and you can tell that the black is really not soluble at all, because it did not go through the chromatography paper. Now that was just an animation. It's not exactly what happens on your paper if you did a chromatography of it. Another type of separation technique is fractional crystallization. So you made these with Miss Erin. You made crystals. So what happens is when you have a supersaturated solution, your solubility rate is going to be much lower than if you had an undersaturated or just a saturated solution. So your solubility limit, as it cools, you will see crystals form. And this is because you have an excess of solute in your solvent, and it starts separating out. So you can see on the crystals that you created, your dissolved substances, which was the borax, became crystallized because you dissolved it in the water. But it was a supersaturated solution, so you had an excess of it, which you had an excess of crystals. So those are the different types of separation techniques. If you are not here for the crystal lab, I'm going to show you a quick video of what happened.
Hello everyone, it's Emmy. Welcome back to another Kiddo Craft. Today I'm going to show you how to make this. Look at these beautiful borax crystals. Aren't they gorgeous? So you just need a couple ingredients: borax pipe cleaner, some water, some heat. It requires some stovetop and heat, so make sure there's some adult supervision for this. But yeah, it's well worth it. Look at these beautiful crystals. When I was a kid, I was obsessed with rocks and crystals, and so I am so excited to see this project. So yeah, let's go in the kitchen and I'll show you how to make this. So you're going to start off with taking 3 white pipe cleaners and twisting them into a kind of loose coil. Something kind of like this, but feel free to shape and bend it any way you like. Next, tie a piece of thread to your coil. So I'm doing this in a Pyrex beaker because I happen to have one, but you certainly don't need to do so. You can do this in a pan as well, and then just pour the solution into a nice glass container to grow your crystals. So the secret of getting really fat crystals is making a really super saturated solution. So the way to do that is to have some really hot water, and you're going to want to actually get it boiling, and then you're just going to add borax. You can find borax in the laundry section at your big box store. So you're going to add borax to your boiling water. Keep pouring it in, and your solution will get cloudy. You'll actually see the borax kind of collect at the bottom, and that means you can't add any more. So I used about 1 liter of solution, and it took about 1.5 cups to 2 cups of borax. So once your solution is super saturated, then you can add your dye if you like. I'm just using regular old food coloring, and for the first crystal I did, I added about 20 drops of the purple neon food coloring. Next, you're going to attach your pipe cleaner to a bamboo skewer, and then dunk the whole thing into your solution while it's still hot. Then cover the whole thing with a piece of cardboard and allow it to sit at least 8 hours or overnight. So 12 hours later, this is what I got, a beautiful crystal. So here's the solution for my first crystal. So then I put it back on the heat, and I brought the solution back to a bowl.
Okay, so she basically does it again, and she makes more crystals. Now, the crystals that she made were using some of the borax, but because she had a super saturated solution, she still had some borax left, so she's able to make more crystals. Now, if she would have had an undersaturated solution, no crystals would have formed, or if she had a saturated solution, she would probably only be able to do make one set of crystals, and it probably would not be as thick as it would as if she had a super saturated solution. So if you have any questions about separation techniques, you need to ask Miss Quinlan.